Women's health is governed by a complex network of hormones, metabolic pathways, and nutrient-dependent biochemical systems that evolve across different stages of life. From menstrual cycle regulation and fertility to metabolic stability and healthy aging, female physiology is influenced by how efficiently these biological systems function. Subtle genetic variations within these pathways can influence how hormones are synthesized, metabolized, detoxified, and how tissues respond to them. The Women's Health Panel has been designed to evaluate these foundational biological processes through a precision genomics approach. Why genetic insight matters. Traditional laboratory tests provide a snapshot of current hormone levels or metabolic status. However, genetic analysis offers insight into the underlying biological tendencies that influence how these systems function across the lifespan. By evaluating key genetic pathways involved in hormone signaling, reproductive biology, metabolic regulation, inflammation, and micronutrient utilization, this panel provides a deeper understanding of female health at the systems level. What the panel evaluates. The Women's Health Panel analyzes carefully curated genetic variants associated with hormone synthesis, hormone detoxification, ovarian reserve dynamics, fertility signaling, metabolic regulation, and cardiometabolic balance. It also evaluates pathways related to insulin sensitivity, lipid metabolism, inflammatory signaling, and vascular interactions that influence long-term metabolic health in women. In addition, the panel examines nutrient-dependent biochemical pathways, including B vitamin methylation, vitamin D activation, antioxidant vitamin utilization, iron balance, magnesium metabolism, calcium signaling, choline utilization, and vitamin B12 metabolism. Each genetic marker included in this panel has been selected based on biological plausibility and evidence linking it to functional endocrine and metabolic outcomes. Categories covered in the panel. Overall, the Women's Health Panel evaluates genetic pathways across 4 major biological domains that influence hormonal balance, reproductive health, metabolic regulation, and micronutrient physiology. The first category is hormonal, homeostasis, and metabolic pathways. This category focuses on genetic pathways involved in hormone production, hormone signaling, and hormone detoxification. The traits assessed include hormone detoxification and cellular protection, estrogen synthesis and aromatase regulation, estrogen biotransformation, phase 1 and 2, progesterone, signaling and luteal phase, stability, androgen conversion and sensitivity. The second category is reproductive longevity and life stage adaptation. This category focuses on genetic markers that influence fertility signaling, reproductive hormone balance, and ovarian aging patterns across different stages of life. The traits assessed include fertility readiness and cycle robustness, FSH regulation, LH regulation, AMH regulation, prolactin regulation, endometriosis, susceptibility, ovarian reserve profile. The third category is female endocrine metabolic health. This category evaluates how endocrine signaling interacts with metabolic pathways involved in insulin regulation, lipid metabolism, vascular health, and cellular energy production. The traits assessed include thyroid function and hypothyroid, risk regulation, thyroid, estrogen, regulatory interaction, glucose regulation, and insulin sensitivity, female-specific insulin response, susceptibility of PCOS, lipid metabolism and fat handling, adiposity regulation and body fat distribution, energy expenditure, and mitochondrial function, blood pressure, and vascular metabolic interactions, cardiometabolic inflammatory response profile. The fourth category is micronutrient pathway efficiency. This category evaluates genetic pathways that influence how efficiently the body processes key micronutrients required for hormonal balance and metabolic health. The traits assessed include B vitamin methylation and 1-carbon metabolism, vitamin D activation and receptor sensitivity, antioxidant vitamin utilization, iron regulation and menstrual iron resilience, magnesium utilization and neurohormonal stability, calcium metabolism and bone signaling choline utilization and methyl load balance, vitamin B12 utilization report components. Each trait within the report includes detailed genetic and clinical interpretation. The report provides information about the relevant genes involved, the specific SNPs analyzed, and their biological roles. Results are categorized into high, medium, or low genetic risk based on additive SNP scoring models. For each trait, the report also provides evidence-based insights related to nutrition, lifestyle, targeted supplements, and laboratory assessments that may be considered for clinical follow-up. Together, these insights help translate genetic findings into practical strategies that support personalized female health optimization.